All right, doing the last two example problems here. We have FeCl3, which I tell you is aqueous, plus solid magnesium gives way to magnesium chloride, which is, we're going to have to figure out what that is, plus iron, which again, we're going to have to figure out what that is. Looking at the solubility rules, so we can do the magnesium chloride. Most chlorides are soluble except silver, mercury, lead. Well, this is not silver, mercury, or lead, so that means magnesium chloride is soluble. So we put aqueous. Then you have iron. This iron is all by itself. It has no charge, which means that this is pure elemental iron. And iron at room temperature is a solid. So we ionize what's aqueous. If it's solid, we keep it together. So since this iron is bonded to 3 chlorines, that means we have iron with a 3+ charge. Oh, I need to balance. Gosh, I keep forgetting to do that. So we got to do a 3 and a 2, and then a 2 and a 3. Okay, so we have 2 irons plus 2 times 6, or 2 times 3 is 6 chlorines plus 3 magnesiums gives way to 3 magnesium ions plus 6 chlorines plus 2 iron. Now we're going to cross out what's the same. So our 6 chlorines can go. Now we have 3 magnesiums on one side and 3 magnesium ions on the other. These do not cancel out because they are not the same. This one does not have a charge. This one does. This one is elemental magnesium, that silver stuff that we've used in class before. You know, we lit it on fire and it was really, really bright. This is ion magnesium, magnesium ion. This is magnesium that has been dissolved. This is the magnesium that you need in your diet, not this one. If you ate this magnesium, it's going to cause a lot of problems in your body, but you actually need to eat this one. So we can't actually cross anything else out. And so our net ionic equation on this one is 2 iron ions plus 3 magnesiums gives way to 3 magnesium ions and 2 irons. Looking at this going, this is not balanced charge-wise. Oh well, we're not going to worry about balancing charges right now. So this is it. This is not a double replacement reaction, so that means that this solid right here, not a precipitate, because you can only get precipitates from double replacements. This is what's known as a redox reaction. Don't really have to know about that just yet. You'll learn plenty about that once you get to AP Chem. All right, last example that I'm going to do is number 8. So number 8 says BaBr2, which I tell you is aqueous, plus sodium sulfate, which I also tell you is aqueous, and that's all I told you. So it was up to you to predict the products. But of course this is a double replacement reaction, so it's pretty easy. Just swap the cations. And you're going to get sodium bonding to bromine. Since sodium's a +1, bromine's a -1, that formula is just NaBr. We'll have to figure out what state it's in. And then barium bonding to sulfate. Well, sulfate's a -2. Barium is in group 2 on the periodic table, so it's a +2. So +2 and -2 is just a 1-to-1 ratio. So BaSO4. And again, we'll have to figure out what that is. So now we go down to our solubility rules. And we say, okay, sodium bromide. Well, right here it says most sodium compounds are soluble, so there's a vote for aqueous. And then the bromine, in your books, remember I told you to cancel this out, and instead of the word chloride, put the word halide, because most halides, anything in group 17, are soluble except silver, mercury, and lead. Sodium is not silver, mercury, or lead, so that means that this particular compound is soluble, so we write aqueous. Then for the barium sulfate, we need to look for the words barium and sulfate. Right here, most sulfates are soluble except those of barium. So that means barium sulfate is not soluble, so that's going to be a solid. Let's get this guy out of the way. Now, come up here, we're going to ionize everything that is aqueous and keep together everything that is soluble. I'm sorry, everything that is solid, not soluble. Do I need to balance this thing? Yeah, let's put a 2 right there. Alright, so we got barium ion plus 2 bromine ions plus 2 sodium ions plus a sulfate yields 2 sodium ions plus 2 bromine ions plus barium sulfate solid. Cross out spectator ions. So we got 2 bromines, we got 2 sodiums. That leaves me with my net ionic equation of barium ions plus sulfate ions gives way to barium sulfate. And that is all there is to it. If you still have questions, I will be here tomorrow morning at 8 o'clock, and you can ask then, or you can ask during class. We might have a little bit of class time tomorrow. Actually, we'll have a lot of class time tomorrow because a lot of you guys are taking that history exam. So those of you that are in class tomorrow, you can ask questions if you have them. If not, just come in for tutoring times, and I will help you out as best I can. Adios, y'all.